Hi friend, welcome to Pure Mathematics channel. Uh, it is class math for beginners or part of arithmetics. Dear friend, please subscribe on my channel. It is class 6. Today our title is prime factorization. Here in this class we will explain two concepts, prime factorization and GCD of numbers. First, we want to define prime factorization. We define as prime factorization as changing a composite number into product of prime numbers is called prime factorization. It is the definition of prime factorization. Changing a composite number into product of prime numbers is called prime factorization. Before explaining the methods how to factors composite number into prime number into product of prime number, we want to explain power of number. Power, because it is necessary when we want to explain the prime factorization, we have to know a little about power. We explain the meaning of power by the following example. If we have number 1, if we have 2 times 2 times 2, it is equal to how many times they are multiplied? 3 times. We have 2, so we can write 2 power 3. It is equal to 2 into 2 into 2. 2 times 2 times 2, it is equal to 8. Here 3 is exponent. 3 is exponent of 2. Number 2, 3 times 3, it is equal to 2 power 3 to power 2. Here 2 is the exponent of 3. Whole 3 and 2, all of them is called power. 3 power 2, all these 2 power 2 is called power, but 2 is exponent of 3. 3 is base. It is equal to 9. Number 3, 4 into 4 into 4, it's equal to 4 times 4 times 4, it is 3 times, it is equal to 4 into 4, 16. 16 into 4, 64. It is the result of the power. Number 4, 1 times 1 times 2 times 2, it is times 2, it is equal to 1 2 times 1 by 1 power 2 times 2, 2 we have 3 times, we can write 2 power 3. That is 1 repeated 2 times, so multiply 2 times 1 power 2 into 2 multiply 3 times, so 2 power 3. It is the concept of power. Here 3 is exponent, here also 3 is exponent, here is 2 is exponent, here 3 is exponent. It is equal to 1 multiplied by 1, 1, 1 multiplied by 2, 2, 2 multiplied by 2, 4, 4 multiplied by 2, 8. Number 5, 5 multiplied by 5, multiplied by 5, multiplied by 5, multiplied by 5, multiplied by 5. How many times? 1, 2, 3, 4, 5, 6. 5 power 6. When we multiply these fives, so we get the result. 5 times 5, 25. 5 times 5, 25. 5 times 5, 25. Or we can write 25 power 3. It is equal to 25 into 25, 6,625 into 25. It is equal to, if we multiply 25 by 625, we get 15,625. It is the result. Like this we can bring another examples, but I think it is enough you understand the meaning of power. In the method of prime factorization, we use from the concept of power, so that I explain here shortly. I explain the meaning of power. Now we want to explain how we can find the prime factorization of a composite number. Here we want to explain this concept, these methods. Here we use division. We use the division operation to change a composite number into prime factors. Example: change the following numbers into product of prime number. Product of prime numbers. Number 1, question 1, 12. Question 2, 18. Question 3, 42. Question 4, 90. Question 5, 120. Question 6, 180. Question 7, 720. Question 8, 225. We want to find prime factor of product of prime factors, these 8 numbers. Solution number 1, we had 12. Here is 2 methods. First one, 12, we write 12 here. 2 into 6. 2 into 6, it will become 12. Now 2 is prime number. It is okay, but 6 is also composite number. Then 2 into 3. Here we got the final. Here we have 2, here we have 2, we have here 3. These numbers are prime number. Therefore, also we can write here 2, we write here, we bring down. If we multiply 2 in times 2 times 2, 3, it is equal to 12. Therefore, 12 decomposed by 2 times 2 times 3. It is equal to, by using the concept of power, we can write 2 power 2 times 2 power 1, because we have 3 power 1, because we have 1 3 and 2 2, so we can write 2 power 2 and times 3 power 1. Another method also here is, and we draw a vertical line, then the right side we write 12 and the left side we write the minimum prime number, which is 12 is divided by, can divide by that number. 2 is a smallest positive prime number, which is divides 12. 2 is a divisor of 12. It is a prime number, a smallest prime number. So 12 divided by 2, 6. 6 also can divide by 2. 6 divided by 2, here is 3. 3 divided by itself, actually we decompose, change it, that composite number 12 into these 3 numbers. 12 is equal to 2 times 2 times 3. It is equal to 2 times 2 power 2 times 3 power 1. It was the first number. Second number we had 18. Second number, it's number 2. Also, as like this, like question 1, we can solve this question also. 18 divided by 18 decomposed by 2 and 9. 2 is prime number, it's okay. Here 9 is a composite number. Also we can change it, 3 into 3. Here 3 is prime number, here 3 is also prime number. So 18 change it to 2 times 3 times 3, it is equal to 2 power 1 times 3 power 2. It is the prime factorization of 18. Also 18 can decompose as like this. 18 divided by 2, 9. 9 divided by 3. 9 divided by 3, 3 divided by 3, 1. Here 18 is equal to 2 power 1 into 3 power 2. Number 4, number 3. Question 3, we had question 3, we had 42. 42, we want to find the prime factor of 42. It is divided by 2 times 21. 21 is composite number, also we change it to the prime number. 3 times 7. Here 3, 7 and 2 are primes. So 42 change it to the prime factor 2 times 3 times 7. All of them has power 1. 42 also divided by 2. Divided by 2, 2 divided by 2, 1. By 3, 21 divided by 3, 7. 7 divided by 7, 1. Here also same answer we got it. Two times 3 times 7. Question 4. Question 4 was 90. 90, when we divided 90 by 2 times 45, it is divided by 3 times 15. 15 divided by 3 times 5. Here these are prime numbers. So 90 is equal to 2 power 1 times 3. We have 2, 3. So we can write 2 power 2, 3 power 2 and 1, 5. 5 power 1. Question, in this question 90 also can decomposed as by 2. 9 divided by 2, 4. 1 we have here, we carry the 1 next to 0. It will become 10. 10 divided by 2, 5. Here 45 cannot divide it by 2, so 45 can divided by 3. 3 divided by 4 divided by 3, 1 time. Here we have 1 carry the number 1 next the left side of 5. It will become 15. 15 divided by 3, 5. But again by 3, 15 divided by 3, 5. 5 divided by 5, 1. 90 is equal to 2 to the power 1 times 3 to the power 2 times 5 to the power 1. It is the prime factor of 90. Question 5 we had. Question 5 we had here 120. So 120 by 2 into 6. 60. 2 into 3. 30. Oh, sorry. 30. 2 into 15. When we multiply 2 by 15, it will become 30. And 15, 3 into 50, 3 into 5. So here we got it. These are prime numbers. These are prime numbers. So 20 is equal to 2 to the power 3 times 3 power 1 times 5 power 1. Also we can find the prime factor of 120. as followed. By 2, 12 divided by 2, 6, 0, 60 divided by 2, 30, 30 divided by 2, 15, 15 cannot divided by 2, can divided by 3, 15 divided by 3, 5, 5 divided by 5. The procedure over. So 120 it is equal to 2 power 3 into 3 power 1 into 5 power 1. It is the prime factor of 120. Now we want to explain the next topic, which is greatest common divisor or GCD. Someone they say greatest common factor, then write GCF. Both of them same, factor or divisor. Here we want to explain this concept. Definition: the biggest number that divides evenly into each number in a given set of numbers. It is the definition of greatest common divisor. It is the biggest number or largest number, which is the given numbers can divided by this number or divisible by this number. It is the definition of greatest common divisor. Here we want to explain the method by using prime factorization we can find GCD of numbers. First, we change the given numbers into product of prime numbers then we multiply those numbers which are joined and have the smallest exponent. The smallest exponent. The result of product is the GCD of given numbers. It is the method of finding GCD of two numbers. By using prime factorization, we can find GCD of numbers. First, we change the given numbers into product of prime numbers. Then we multiply those numbers which are joined and have the same the smallest exponent. The result of product is the GCD of given number. First of all, when 2 or 3 more than that numbers giving us, we want to find the GCD of them. First, each separately we change it to the prime factors. We find the prime factors of each others. After that, we write all of them as exponent, as power. Then we choose those number which they are joined in all primes and has the smallest exponent. Then we multiply all of them, and the result is the result of product is GCD of the given number. Example, here we want to explain this method in example. Find the GCD of the following numbers. Number 1, 12, 18. Number 2, 15, 35. Number 3, 120, 150. Number 4, 240, 360. Number 5, 40, 24, 32. Number 6, 360, 280, 330. Number 7, 60, 90, 120, 180. We solve 1, 2, and 3. Also 5, 7. 1, 2, 5, 7. Others we will remain in other question as your homework. First, we want to solve question 1. In question 1, we want to take another paper. Question 1, we had 12 and 18. Question 1, 12 and 18. First, we as we explain in methods, first we find product of prime numbers. We change these numbers to product of prime numbers. 12 is equal to, if we change it, this 2 to power 2 times 3. 18 is equal to 2 power 1 times 3 power 2. You know the prime factorization. You know that, so we here through we write the result. Now if we want to find GCD of 12, 18, it is equal to, here 2 to the power 2 to power 1. Which one we should take? Those number which is joined in both prime factorization. So we take that number which has the least exponent. Here 2 power 2. We have here 2 power 1. We should take 2 power 1 because 2 power 1 has 1 is less than 2. So we take 2 power 1 times, here we have 2 power 1, here we have 2 power 2. Which one is less? Here 2 power 1 has least exponent. So we take 2 power 1. It is equal to 2 power 1 is itself, 3 power 1 is also itself, equal to 2 power 2 times 3, it is equal to 6. Therefore, the GCD of 12 and 18 is 6. Question 2, we had 15, 35. First, if you do not know, first we want to find prime factors of 15 by 3. 15 divided by 3, 5. 5 divided by 5, 1. 35 divided by 5. 35 divided by 5 is 77. 7 divided by 7, 1. So 15 is equal to 3 power 1 times 5 power 1. 35 is equal to 5 power 1 times 7 power 1. Here we have 5 power 1, 5 power 1. From these two, we take one of them. But here we have 3 power 1 and here we have 7 power 1. But they are not joined, we do not take them. So GCD 15, 35 is equal to 5 power 1 is itself, for 5. GCD of 15 and 35 is equal to 5. Second number we want to find 40. Question 5. 40, 24, 32. Question 5. It is question 1, question 2, question 5. We had GCD 40, 24, 32 equal to question mark. Here first we want to find prime factor of 40. Divided by 2. 4 divided by 2, 2. 0, we take it down. Here 20 divided by 2. 2 divided by 2, 1 and 0. 10 divided by 2, 5. 5 divided by 5, 1. 40 it is equal to 2 power 3 times 5 power 1. Also 24 divided by 2. 2 divided by 2, 1. 4 divided by 2, 2. 12 divided by 2, 6. 6 divided by 2, 3. 3 divided by 3, 1. It is equal to 2 power 3 times 3 power 1. Next number 32. 32 divided by 2. 32 divided by 2. 3 divided by 2, 1. We have 1. We carry the number 1. The left side of 2, it will become 12. 12 divided by 2, 6. 16 divided by 2, 8. 8 divided by 2, 4. 4 divided by 2, 2. 2 divided by 2, 1. It is equal to, we have 2 to power 5. 2 power 5. Therefore, now we can find GCD 40, 24, 32. It is equal to, here we have 2 power 3, here we have 2 power 3, but here we have 2 power 5. Which one is the least? Here from these two number, one of them, we choose one of them. Here we have 5 power 1, but we don't have any other two numbers. Here we have 3 power 1, but we don't have any other numbers. Therefore, 2 power 3, it is equal to 8 is the GCD of 40, 24 and 32. The 7 number we have here 60, 90, 120, 180. Here we want to solve this question. Here we stop the video and write in the prime factorization, which the length of video should be a little less. So here when we change 60 to product of prime factor to the power 1, 3 to power 1, 5 to power 1, 90 to power 1, 3 power 2, 5 power 1, 120 2 to power 3, 3 power 1, 5 power 1, 180 2 power 2, 3 power 2 and 5 times 5 power 1. Here now we want to choose the GCD of this number. GCD 60, 90, 120, 180 is equal to, here we have 2 power 2, but here we have 2 power 1, 2 power 3, 2 power 2. Which one is the least one? Here we choose this one, 2 power 1 times, here we have 3 power 1, 3 power 2, 3 power 2. It is the least number, so 2 power 1. Here we have 5 power 1, 5 power 1 and 5 power 1. From all of them we take one of them, 5 power 1. It is equal to 2 times 3, 6 times 5. It is equal to 6 times 5, it is 30. Therefore the result is 30. Other question is your homework. Thank you. Please subscribe my channel if you understand this lesson.